Good afternoon. I deeply appreciate you all sticking it out till near the end. Quick question before I get started. I think there was an email that went out that requested very nicely that if you installed Visual Studio Code, Python 3.74 or newer, and Node, that you'll be able to join everybody in making lights flash impressively, which really is why I got into this business. I've been doing this for more than 30 years, and I really did get into it initially because I wanted to make lights flash impressively. And ironically enough, full circle, I come back here, and the whole point of today's presentation is to make lights flash impressively. Now, the little device we're going to be playing with, the one you see on the screen there, is probably got more power than the computers I first wrote code for, and it's about that big. So my name is Mark Schramm. I'm a Microsoft MVP in Windows development, so my happy place is writing C# code, and Windows applications. This is a project that we'll talk a little bit about that was developed by the Microsoft Garage interns last summer. So what we want to go through, I do have a button here, I should use that. So we'll talk about who the team was that built it a little bit. We'll talk about what is the physical device that we're simulating, and then we'll go deep into the simulator, and then I hope that everybody here with laptops and all the prerequisites installed are able to write some code and make lights flash impressively. It's a theme we'll go through. We'll do a few other things as well. Now, I'm wondering if this microphone is drifting in and out every time I turn my head. We'll see if that's better. So last summer, a set of interns in the Microsoft Garage, it's just around the corner there, had as a project to create a simulator for a microcontroller called a Circuit Playground Express from Adafruit. And what they did is they built that very thing to run in Visual Studio Code on multiple platforms and allowing it to do some really magical things. And we'll talk about what those magical things are as we move through the code and start implementing some abilities to do things. The interns built this, but with a lot of support. The Microsoft interns that come in here get support from a number of coaches that are Microsoft full-time. They get support from a sponsor team that provide them with the tools they need to accomplish what they did. It involved a designer, program manager, and a bunch of software engineers. That's the team there. They're all doing various things, some in school, some working other places right now. But they delivered and exceeded expectations. And the project that I'm about to show you is now released to open source, or has been for a little while. And after we show you what it's capable of doing and what maybe some things it can't do yet, have some ideas on how, as an open source project, you can contribute to that project yourselves. So we're going to be talking about the device. The device is called the Adafruit Circuit Playground Express. It's about that big. It's a microcontroller that does a whole lot of things. One of the things it does really well is it flashes lights impressively. But it does so much more than that. It's got a whole bunch of sensors packed onto this thing. It's amazing how much they pack onto this, and it's super bright. It has the NeoPixels, which are the things you see there. It has a microphone sensor. It has a motion sensor. It has a light sensor built into it. It has a speaker. Hard to find it, but it's on there. It has buttons, switches, all the things you need to really be truly happy. Also around the edges are a whole lot of connectors that you can connect up things like servos or anything else you want to have it control just by using alligator clips or clipping them on or soldering or whatever you want to do. So this is a really neat thing, but not everybody has one of these things. And sometimes when you're writing or you want to write code to make this do what it does, it's a hassle to pull it out, and you got to plug it in with a USB port and send code to it and test it. And there's limitations. Like, for example, it's really hard to debug. You can't send the code to it and single step through it. The code runs on the board. You're sort of limited in what you can do with it. Wouldn't it be nice if you could do all the say you're in an airport or just sitting on a bus or something, and you can work on this stuff and not have to have this with you. And then when you've perfected your code and it's completely bug-free, you can do a single button and have it just deploy to the device and bang, off you go. Make sense? So let me turn this thing off. So what we're going to be doing is showing you how to write code for this without having to have that. This presentation is going to be either really short because none of you are going to help me, or it's going to be, we're going to fill the time up with some really fun things. So let's see what we've got. We've got the Device Simulator Express. Its formal name is Device Simulator Express, a Microsoft Garage project. It was developed by the Garage interns, it was released to open source, and now the community contributes to it and makes it better on a continuing, ongoing basis with regards to security and functions and things like that. It is a Visual Studio Code extension. Visual Studio Code, we all love Visual Studio Code. How many people have Visual Studio Code on their laptop? That's awesome. That's good, because you'll need it in a little while. Visual Studio Code is great because you don't have to just run it on Windows. I do because I have a Windows machine. But Anthony back there, he has a Mac. Are you running Visual Studio Code? It is open source, so the community can contribute to it. You can download the source code from GitHub anytime you want. See how they built it. See what it does. See what the inner workings are. But you don't have to. You can just grab the extension and use it right now with your Visual Studio Code device, or Visual Studio Code software. Now, we're going to be doing that today. We're not going to be downloading the GitHub and looking at the source code. I leave that to you to do when it's convenient for you. That is the GitHub location of the Device Simulator Express. If you want, you can take a picture of it and deal with it later. You can do the coding you want to do, and you do not have to have hardware. So that little flashy light thing I have there is really so I can hold it up in flashlights impressively during the presentation, but it's not required. You do not have to have it. You can do all the work you need to do, learn how to use it, learn how to code to it, figure out what it can do and what you want it to be able to do, and then, once you've done all of that, you get the device, deploy it to the device, and away you go. It's a way to get up to speed very quickly without having to futz about with a bunch of little pieces of electronics. The Device Simulator Express gives you some really nifty things. It gives you full interactive debugging. So when you write your Python code, and we're going to be using something called CircuitPython, basically Python that is deployed to the device or to the simulator, you can do full interactive debugging. So you can put in breakpoints, you can stop as you go through the code, you can do those things that you normally do as a developer, and you don't have to put in a bunch of essentially print statements using the old terminology, which is with the device you have to do that, and then you have to look at a serial monitor and wait for those things to print out to figure out what it's doing. And this, you can actually go in and look at the variables, look at watch variables, things like that. One of the nice things that I appreciate is I come from the world of Visual Studio. Not Visual Studio Code, but Visual Studio, where we started off with IntelliSense. When I write code and I hit that dot, I want to know what my options are. With Visual Studio Code and the extension, the Device Simulator Express extension, you literally can do all of that. So as you write code against the Circuit Playground Express API, you just type in CPX or whatever you called it, dot, and it'll tell you all the different things you have control of. Buttons, switches, neopixels or pixels, the lights on it, things like that. There's templates available on the Adafruit website. Those templates that are used to distribute or to deploy to the device work fine against the simulator. So you can get lots of ideas on how you can control things using the samples and templates that are provided to you. It does have a built-in serial monitor. If you want to go that route, you can do that. And they've also kindly included a nifty little way, just once you've perfected your application, to just deploy it directly to the device once you've tested it against the simulator. Really handy. Any questions about this so far? Everybody's quiet. You want to see what it looks like. Fair enough. Okay, so I'm assuming here that you have hopefully installed Visual Studio Code. By the show of hands, I would say that that is probably true with most people. I'm hoping that you have Python 3.7.4 installed. I did, when I was getting ready for this presentation, I had Python installed quite some time ago. I worked as a technical advisor with the interns on this project, so I had to be able to run it. But I found last week when I tried to go back and run it, Python wasn't working. One of the things you need to remember when you install Python is you have to have Python in your path. And it turns out, because I do a lot of different stuff, you're better to have Python near the top of your path list than at the bottom. Because every time I type Python, it launched the Microsoft Windows Store app and showed me the Python installation. So when I swapped things around, it started working better. And Node. So am I safe to assume we're ready to go with that? We're ready to start writing some code to make things look flashy? Okay. So what you need to do is, first step, get your copy of Visual Studio Code up and running on your laptop. And there's two different ways we can do this. One, we want to install the Device Simulator Express extension. Two different ways we can do it. One is to go to the website, that one. Or the second one is inside Visual Studio Code. And let me just show you. If you go to right here, extensions, you can search for the extension and look for one that looks like that. Install it. Now, that particular application has a lot of dependencies. There's a lot of little utilities and libraries that get installed to let it do the magic it does. But you don't have to install those things. If you've installed Python correctly, the first time you run the extension, it will ask you if you want to install all those things right off the bat. So, now, how many here are planning to play along with this? That's pretty good. Excellent. Okay, so what I'd like you to do is go ahead and install the extension, and then we're going to run it. Now, I hope you're somewhat familiar with Visual Studio Code. I'm not intending to do a training session on Visual Studio Code, but we'll follow through some of the basic things that you can do with it as we go. So, any questions about this? Are you having any troubles finding this? No, that's good. Once you have it installed, if you're installing it right now, just let me know when you've got it installed so I can sort of gauge when everybody's starting to get caught up. So you've got it installed. Anybody else? It's installed. It's a pretty quick install. Python's not so much, so that's why we wanted that ahead of time. So you're good. Okay. So once you have it installed, to run it, we're going to just open up a Device Simulator Express new file. That will open up a Python file of source code that we can then modify to do the things that we want to do. That will also trigger the dialog box that will pop up in the corner asking if you want to install the prerequisites. Now let's just see. Right. So what we do is we go Control-Shift-P, and then you can just type in Device Simulator. It'll filter it down just like you see here and allow you to pick Device Simulator Express new file. You want to open that new file. In the lower right-hand corner, it should pop up a dialog box saying, do you want to install prerequisites? If it doesn't do that, it's been a while since I've installed it, so if it doesn't do that, it may do it when we actually run to the simulator, but I believe it'll do it when you do the new file. Are you finding the prerequisite prompt popping up right away? Yes? You did it last night. See, there's a guy. I like that. That's perfect. And it installed no problem. You can actually install it. I think it installed. Did you have to install it manually? I'm not sure you did. Right. Well, that library is the PyWin32. If you go to the terminal, you can just type pip install PyWin32 if you're on a Windows machine. I'm not sure that is relevant on a Mac, but I'm not sure. I don't have a Mac. I've never actually owned a Mac, so. So when you're at the place where we all want to be at, you should be, I'll get rid of this. You should see something that looks like that, which is sort of the base template for what we're going to do. When you've got that installed, just let me know so we can move on to the next step. If you got to go to the Python website. www.python.org, downloads. Okay. So you'll get something that looks like this. You may have the simulator open, you may not. I'm not sure if you will or not. I did get it open when I ran this. This is with the dark, in my samples when I'm playing with it, I'll use the light one. It's a little easier to see, I think. But basically there's a link at the top that will take you to the Adafruit templates for the Circuit Playground Express. You'll get the same thing if you click on the little helpful tutorials on Adafruit link that pops up in the lower right-hand corner. It'll take you to a web page that looks like this. And it has down the side, on the left-hand side, a whole bunch of links to sample code. And we're going to use those samples so that you don't have to try to type all this stuff yourself. You can just copy and paste it in. So, the first one we want to do is we're going to make one light turn on. On the Circuit Playground Express in the top right, just above the really bright pixels, there's a little tiny LED red light. And what we want to do is we want to have that come on and turn off. Simple enough, just blink. So what you're going to do is you're going to click, I don't even know if that works here. Maybe not. Ooh, too far. Right. So you're going to go click on that red LED, and we're going to look for the second example of the code. The second example has it turn on the light and turn it off. Now you can see in our sample right here that if we paste this code in, and if you don't, this is the code, you don't have to have the internet, it'll run if you just type that in. And it'll cause that LED in the top right of the device to blink impressively. Not as impressive as the NeoPixels, which were blindingly bright, but it's still cool. On the website, oops, sorry. If we click on the red LED, and we skip the first example, which just turns the light on and does nothing else, which, you know, is kind of boring. The second example, they call Blinky, turns the light on and makes it blink. So if you get the light blinking, I should point out something that I didn't. Once you've written that code, you'll see a toolbar that looks like this up here on your code window. And that toolbar has a number of useful buttons. The center one, which is the play button in a box, if you push it, will, if it's not already running, launch the simulator, deploy the code to it, and run it. So you'll get your light blinking. So, anybody, when you have it running, hold up your hand, let me know. So we've got a runner there, runner, another one here. So that's good. We're off to a good start. You guys have got it running there? It's a socket I/O error. So you're running on a Mac or that's a Windows device? Oh. Okay, well, I didn't, before I come here, test it. I think it's supposed to support running on Linux, but I'm not sure. I don't know the correct answer to that. In the interest of time, I think we'll move on to the second sample. And I apologize, but please just keep plowing through it. The second sample is where we're going to use those pixels, the NeoPixels. They're multicolor. They support the full RGB range. And what we want to do is we want to turn them all red and turn it on. And what we're going to do is we're going to go into that sample code page again, the web page, and look for the one that says NeoPixels, which is close to the middle. And inside there, we're going to take the first sample, which is really simple, 3 lines of code. That looks like that. And by the way, if your first one is running still, just hit the little stop button underneath the Circuit Playground Express, the Device Simulator Express, and it'll stop that code from running and you can go ahead and proceed. Now you may have received, when you ran it, a message in the lower right-hand corner saying, if you want this to run on the physical device, you should name your code one of 2 names. It's not necessary for the device simulator, but if at some point you want to deploy it to a physical device, you'll want to rename your code and run it and deploy it. Otherwise, it won't deploy or it won't run. So this one's pretty simple. Oops. This is what the code, oh, this is the flashy red light. Oh, I don't have that one. Well, we'll just add it. And just so we know, that first one, the from Adafruit Circuit Playground Express, that's the SDK directly from Adafruit. We call it CPS, so I'm going to run it. It wants me to save it. And it wants it to be code.py or main.py. We're fine with that. And you can see that all my lights turn on. It's a super simple demo, but it is strangely gratifying. How are we doing with that one? Pretty easy? We're going to get more difficult, I promise you. I'm kind of trying to remember what time I've got till. I've got until 4:30, right? Oh, he's gone. Okay, well, we'll just wing it. Okay, once we've got this one running, it's time to start getting it to do things. So we want to do an animation a little bit. So, actually, before we do that, we'll show you another aspect. So those NeoPixels are really bright. When you see it on the physical device, you saw how bright it was. It was blindingly bright. do have the ability to control the brightness simply by saying cpx.pixels.brightness, and then you can set it to a number basically between 0 and 1. A number basically between 0 and 1. And you can set how bright you want it to be. You can just modify the code you just built to change the brightness to be 0.3. That's how, with this thing, when it's running, it's not very bright to start with because I have the pixel brightness set down, and then all of a sudden, let's see if I can see it, it'll suddenly flare up and be really bright because now we're at 100%. It gives you some flexibility in how you use it. If you go to the Adafruit site, you can buy all kinds of accessories for it, things like, as I said, servos or display screens, all kinds of things that you can just clip on to this device and have them controlled by your microcontroller. It's really slick. Okay. Now this is where you guys have to do a little bit of work. So what this is what we want to try to do is take the basic code that you've already figured out, in other words, how to light up all the neopixels, but change them so every single one is a slightly different color. So you end up with a rainbow variety. The idea being everything is nicer in a rainbow. So ways you can consider doing this is you can simply directly address every single pixel and set it to an RGB color. So you can set it to be like what you see down here, 0x and then 6fs. Online, you'll find RGB codes, or we can cheat a little bit. Close that. And all I did is set all the different pixels to be different colors. So I'm going to give you a few minutes to do that. If anybody has any questions, I'm happy to walk around and look at these things. Anybody having any troubles, any questions? Now's a great time as we muddle through these. I'll put the other page back up. We're not doing anything fancy. We're just going to turn on the pixels. Don't worry about turning them on. Every single one with a different color, and we'll see how it looks. Every time I get too close to the mic, I can see Cody at the back jump. Anybody have any questions so far? Yes? Yes. I can't see things that are small. Okay, so let's look at this. Oh, it's not a touchscreen, is it? So you're turning on just the red LED. You're turning on one. You're turning on this thing here. That's the red LED. To turn on the pixels, the color ones, you have to do cpx.pixels, and then, because it's an array, say 0, 1 through 9, and then set its color to be something, then it'll turn on. The LED is not the same as the NeoPixel. The LED is just a really simple, low-power flashing indicator that you could use to indicate the power's on, to indicate. The NeoPixels are more communicative. It gives you the ability to change the colors, set patterns, blink in different orders, do things that you would want to do with it to communicate more of a message or more information than you could do with a single pixel, a single LED. Anybody else with a question? It can. It can actually play music. It can do a number of things. And we'll go through some of those things that it can and cannot support, and perhaps there's some ideas that you can come up with I made up the colors. It's not really a rainbow. Yes, sir. I got 5 minutes left. Okay. I'm going to let you play around with that. Meantime, let's talk a little bit about what its capabilities are and what it's not. So this is sort of a matrix of the capabilities of the Adafruit Circuit Playground Express API's abilities and what has been implemented by the Device Simulator Express. I hope it's up to date. I think it is. So what you have is you have a lot of different sensors on board. You have NeoPixels, the ability to turn them on and off, change the colors, change the brightness, all those things. We fully support that. Buttons, there's a number of buttons on the front that you can tap, and that allows you to provide feedback or do things. You can turn things on and off, whatever you want to do. You have the ability to play WAV files, music. One of the things that you want to be able to do, which is tones, you know, the beep, 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 the whole R2-D2 thing, is not currently implemented in the Device Simulator Express. This is an opportunity, an open source opportunity. If you think you would like to see this, contribute. Open it up and add the functionality. The API does support it. It just didn't get implemented in time. The interns only had a very finite amount of time to implement as much as they can, and it's remarkable what they built in just 16 weeks. It's amazing. So there's a light sensor that tells brightness and darkness, so you can tell if you're in ambient light or not. There's a temperature sensor. One of the nice things about the Device Simulator Express is there's buttons below the simulator that allows you to set things like the room brightness to simulate it. There's a way to simulate motion or temperature. You can do those things with a slider bar, and you'll get feedback into the code that you can then write your code against. Motion sensor, including the ubiquitous shake, capacitive touch sensor. The sound sensor, it has the ability to hear, but the API from Circuit Playground Express, from Adafruit, does not support that. Again, an opportunity, perhaps you can find a way to implement it. Green LED, red LED, those are the two lights at the top. There's a switch slider in the middle, and you can use it for turning the thing on and off, whatever you want to do with it. And then the IR transmitter and receiver, you can create the ultimate remote control if you wanted to. Again, the API does not support that, so it's an opportunity, again, for open source development. We welcome, or the project welcomes your input, of course. The last one that's kind of fun, we're not going to have time to do this one, so we'll do some questions and things, but basically it would be nice to be able to interact with more than just the lights, so I'll just show you what I did. One was to create the rainbow, but animate it. And all I did with it is I created a loop, put a time wait after each light, and had it light up. And then each time I went through the loop, it shortened the wait time in between. So if you watch it, it's mesmerizing. It's exciting. The wait times will get less and less. It'll start going faster and faster until it's spinning around. What more fun could you have, right? I have way too much spare time. So you can see down here all the buttons where we can simulate things like the ambient light or motion sensor. You can hit the button and have it shake, or you can indicate the motion of the device. And the last one was one that which was interacting with some of the buttons. And all this code is available on the Adafruit website as templates. So with this one, it doesn't do anything until I flick this little switch, which is actually a physical switch on the device, that causes it to start running. So it's interaction with the physical, not just sending a bunch of lights to the device. Does anybody have any questions about this thing? Yes, sir? Okay, so it's a good question. The device, you see around the edge, I don't know if this thing has a laser pointer or not. Maybe it does. Maybe it doesn't. Okay, I'll use the mouse. So you'll see all around the edge, these little holes here. They're actually not just holes. What they are on here, and you guys can come up and look at this afterwards, they're connectors. And you can connect anything you want to it, and you can communicate with those and send signals. You still have to have some way to control the device that you're sending. So you can't just turn a light on and off. This is a low-powered device, right? But you can use this to send signals to that thing that controls those lights. You can do it. You'd have to write the code for it. Yes? It does have an IR sensor, but the physical device has it. The device, Simulator Express, am I incorrect? Yeah. So again, if you wanted to write it with the device, you can do it. If you want to do it with the simulator, somebody in this room perhaps would have to create the ability to do it, submit the PR, and away you go. We'd love to see it. Beg your pardon? No, there's not capacitive touch. There is a motion sensor in front, so it can see movement in front of it. So there's an eye, essentially, on it. And you do have 2 buttons and a switch that you can interact with, but it's not a capacitive device.
I'm pretty sure that some of those connectors are capacitive touch sensors as well.
Yes, some of the things you can get from the Adafruit website there's a huge swath of things that you can get.
Built right into.
Oh, those things?
Yeah, some of those connectors are. They will, if you put a finger on them, they will trigger.
That's entirely possible. Only some of them, though. I think you're right. I think there's a couple of them that will trigger if you physically touch them. But it's not like a phone type thing. It's more just some kind of contact with it will cause it to send feedback to the code. Thank you. Good point. Somebody who's played with it. Anybody else? Yes?
So the microcontroller is using MicroPython?
Yes. No, it's using CircuitPython, which is, I guess, a flavor of MicroPython. But it's if you go to the Adafruit website, they call it CircuitPython.
It's limited to this board?
This particular application? Correct. This particular application, but I believe the architecture is designed that more can be added in the future. But right now, this is the one that was built. Again, 16 weeks. They have a limited amount of time.
And can you debug stuff with the simulator running?
Yes. With the simulator, you could put breakpoints in your code. Now, this is where you diverge from your demo, is always interesting. Oh. I put a breakpoint in. Stop it. It's been a while since I've done this. Nope. I guess I have to do something else. It is possible. I just can't remember how to turn that on. I don't know. Stefan, do you remember? Oh, that's right. No, I'm not sure that's the way to do it either.
Well, let's, do you want to take one more question, Mark? Is there
Yes.
one more in the audience? Quick one?
We can sort it out later. I'll sit at the back room. I'm more than happy to answer questions or play around with it. Anybody else have any questions? Yes. Yes, well, this is what this is doing, right? The simulator, of course, has to be running on some device, but this thing here, the only thing that's plugged into that is a battery pack. So this thing here can run completely independently. It doesn't have anything. Once you've deployed the code to it, it just runs. The only thing I had to do is turn on the battery, that's it. And off it runs. There's nothing. Yeah. This is actually that last program I was running, doing the flashy lights and stuff. I deployed it to this just before the session started. So thank you.
Perfect opportunity for me to sneak out and show one of these things in action. Wait, hold the applause. This is part of the same presentation. This is from a 3D model that I got online of the big Game of Thrones dragon breathing fire on a table, and it's powered with a Circuit Playground Express. Oh, that I have to turn on. Oh, demos.
It's ad hoc.
It was. That power's dead. Okay, yeah, that one's dead. It was working, I swear.
Plug it in up here, maybe. Or back here? No, it won't reach.
Yeah, using the same demo that you just went through with some interesting flashy lights. There we go. And the dragon's still printing, but when it's done, it hangs off this, and it looks like it's breathing this beautiful cone of fire. So it's pretty fun what you can do with this stuff.
You know that question you asked me earlier? Yeah, one of those.
Yeah. Right. And we don't. Oh, sorry. Oh, lift it up. Yeah. We don't. I don't think we have any kind of deal with Adafruit on these, but I highly recommend buying one of these. They're like $26 for the device. Like, just get it to play with. They're great toys.
$24.95
Yeah.
US.
And there you go.
But you can actually get kits that include servos and all kinds of things where they discount it a huge amount. It's super cheap.
Okay, thank you, Mark.
Thank you.
So at this time, we're going to set up for a panel discussion. While we're doing that, the bartender will make his way in and set up for the social event. So get up and grab a drink or a cookie, but don't disappear just yet. We got a couple more things. And then the panelists, Luca